So compared to the last question, instead of having multiplication outside of the function, we're now multiplying a number inside the function. So once again, our parent function is y equals f of x. And for this topic, we are focusing on horizontal scaling and its definition. It can also represent horizontal dilation. So let's keep both of those in mind. They can be used interchangeably. So we have two functions, or rather we have one function, g of x equals f of bx, f of b times x, and not the Bronx. If you notice, it is the original function y equals f of x, either stretched horizontally or shrunken horizontally when there's a condition on the variable of b. But it says for both at the end to divide the x coordinates by b. And I wonder why that's the case, why we're dividing by b. Well, that should make sense because if you notice, whenever we are dealing inside the parentheses, like with factors, we always do the inverse operations. Like the zeros are the opposite side from the number displayed in its factors. So if we're multiplying by b, that means the x coordinate should be divided by b. Now, I don't know if that's true or not, but let's see. So let's first sketch the functions. Well, let's plot the points. We have 3 points of specificity. We have the point of 4, 0. Sorry, negative 4, 0. We have the point of 4, 0, positive. And then the point of 0, 8. We're switching it up just a little bit. All right. So we want to graph the function g of x equals f of 2x and h of x equals to f of 1/2 x. So I'm going to go down here. This point is negative 4, 0. So basically that means that f of negative 4 was 0. And over here, this means f of 4 equals to 0. And on top, that represents f of 0 has equal to 8. Okay. Let's start with the f of negative 4. I'm going to go over here. So we know that 0 equals f of negative 4. In this case, the thing that's being affected is the x value, not the y value. So y is going to be 0 regardless. That's not going to change. I kind of want to rewrite my f of negative 4 to match f of 2x. So watch this. I'm going to rewrite this as f of, instead of having negative 4, I'm going to write it as 2 times negative 2 in the inside. Because 2 times negative 2 is negative 4. More importantly, we have it in the form of f of 2x. And in this case, the x is going to equal to negative 2. And this is g of negative 2. Because g of x equals to f of 2x. So that means g of negative 2 equals to 0. So that's going to be the point of negative 2, 0. All right, I'm going to do the same thing for 0, 8. And I want to see, can we display that one more time? So I'll write that up here, that g of negative 2 equals to 0. But in this, I doubt that will change too much. So we have the coordinate of 0, 8. F of 0 equals to 8. So that means 8 equals f of 0. I just wrote it backwards. And I can rewrite this as f of 2 times 0. Because 2 times 0 is still 0. But more importantly, I produced the inside as 2 times something. So that means that my x is going to be 0. And we know that f of 2x equals to g of x. So this is going to equal to g of 0. So hence, g of 0 equals to 8. And that stays the same. So I'll also write it up here, 0, 8. And then we can follow the same pattern for the last one. F of 4 is 0. So 0 equals to f of 4. But then we can rewrite that as f of 2 times 2. Because we know 2 times 2 is 4. And notice here, we have it in the form of f of 2x. X is 2 in this case. F of 2x is the same as g of x. So this is also g of 2. So g of 2 equals to 0. And that point goes right here as 2, 0. And now we're going to sketch this function. As you can see, this function, it shrunk horizontally. It was wider at first, but now the graph has shrunk. It has shrunken horizontally by a factor of 2. And 2 is a number that is greater than 1. So therefore, when the number being multiplied to the x is greater than 1, I'll put here when b is greater than 1, the function shrinks horizontally. It gets smaller, it gets more condensed. Now it says divide the x coordinates by b. In this case, our b is 2. But if you notice, the original x coordinates was -4, 0, and +4. -4 divided by 2 is -2. And remember, we were dividing the x coordinates. 0 divided by 2 is 0, so that stayed the same. +4 divided by 2 is equal to 2. So every x coordinate was divided by 2. Y remained the same. So logic states if the function will shrink horizontally when the value of b is greater than 1, then it has to stretch horizontally when b is greater than 0. But at the same time, that value of b has to be less than 1. The function will stretch horizontally, but regardless, you will still divide the x coordinate by the value of b. But because you're dividing by a number less than 1, the x coordinates will get bigger, as we're going to see here. Okay. So remember, we have the original coordinates is -4, 0, 0, 8, and 4, 0. Let's start off with the 4, 0 this time. We know f of 4 equals to 0. So I'm going to write that as 0 equals f of 4. That's the same thing. Now, I want to get my function, my f function, to look something similar to 1/2 times something. So we have to ask ourselves, and I'll put that in red in this case, half of what number gives us 4? Half of what number gives us 4? And that's 8. So that's 1/2 times 8. Because half of 8 is 4. More importantly, our function is in the format of f of 1/2 times something, times some x. In this case, our x is equal to 8. So that means this will be h of 8. H of 8 equals to 0. So that goes here. If you take 4 and divide it by 1/2, 4 divided by 1/2 is 8. 4 things divided in half becomes 8 pieces. You have 4 cakes and you divide each cake in half. Instead of having 4 whole cakes, you have 8 half cakes. They're now 8 pieces. And the same thing will be true if I did f of negative 4. 0 equals f of negative 4. We want to write our function as f of 1/2 times some number, and that number is going to be negative 8, because half of negative 8 is negative 4. So in this case, our x will be negative 8. Therefore, our function is h of negative 8. H of negative 8 equals to 0. So that's the point of negative 8, 0. And then, as we can see, the top one shouldn't change. That's going to remain the same. We know f of 0 is 8. So 8 equals f of 0. F of 1/2. Well, anything times 0 is 0, so that has to be 0. The x is equal to 0. So f of 1/2 times 0 is the same as h of 0, which means h of 0 equals to 8. And nothing changes. That's still the coordinate of 0, 8. So I'll put that in red as well. Put that up there. And we'll sketch that function. Let me label my function. This is h of x equals f of 1/2 x. And the one in the inside, that is g of x equals f of 2x. And as you can see, for h of x, the function was stretched horizontally. We stretched the function horizontally when the value of b is a number that is positive, so it's greater than 0, but that same value of b is also smaller than 1. All right, that is it for this video. I know these topics are a little bit complicated, a little bit dense. I do believe they should have been taught in high school. But like I said before, I do believe that when you teach these topics in high school, you let students discover these concepts by, setting it up for them and having them have time to practice. And this is how I would teach this in my high school, if I had more control over the curriculum, where students would just play around with numbers for about 2 or 3 days, but it'll be worth it in the end because they will learn something, thus improving their numerical operation skills. I'll catch you in the next one. Peace.